Okay, so we're on to section 5.4. We're about to make things a little bit trickier for all of us. So the conditional probability and the general multiplication rule. All right, so suppose we toss the red die before we toss the white die. And I'm assuming these are six-sided die. I should say a six-sided red die before we toss a six-sided white die. Let's start with that. Before the dice are thrown, what is the probability of the faces? The probability that, boy, I'm really with it, that the faces sum to 3. Well, probability the faces sum to 3 is sum to 3 is equal to the probability of 1 and 2 or 2 and 1, right? Hold on. Pressed the wrong thing accidentally. All right, so probability of 1 and 2 or 2 and 1. Okay, well, that's 1 out of 36 plus 1 out of 36, which is 2 out of 36. Right, we found that way back in the day. Right there, 2 out of 36. All right, so suppose the red die comes up 1. What is the probability of the faces summing to 3 now? All right, now keep in mind, we're saying the red die is 1, which means you're only allowed to look at this top row right here. See it? That's all you're allowed to look at. Forget about the rest of the things. Okay, so the way we write this is we say, what's the probability that they sum to 3 given that the red die is 1? Okay, well, if the red die is 1, there's only 6 options in the denominator, right? Because if the red die is 1, you're really only looking at that top row up there. And the only one that sums to 3 out of all of that is 1 and 2. So it's 1 out of 6. And that, my friends, is your first foray into something called conditional probability. Conditional probability, and the way to notate it is the probability of F. It's a vertical slash E. You read it, the probability of F given event E. So just to back up for a second, this is what we found up here is the probability sum to 3 vertical slash red die is 1, right? And that vertical slash right there means given that, right? Given that the red die is already 1, what's the probability that they sum to 3? All right, so then let's see down here. We have the conditional probability rule. Now, the way to find conditional probabilities for things that are harder than that die problem is you take the probability of F given E is equal to the probability of E and F divided by the probability of E. Or in other words, the number of ways you can have E and F divided by the number of outcomes in event E. All right, let's see here. 2 cards are selected in sequence from a standard deck. Find the probability that the second card is a queen, given that the first card is a king. Assume that the king has not been replaced. Okay, so we want to know the probability of second card queen, given that, there it is, first card is a king. Okay, so in your first card, you've taken a card out of the deck, right? So originally there were 52 cards in the deck, but you got that first card. Oops, hey, come back. I don't know how I managed that. But you got that first card to be a king, right? So now how many cards are left in the deck? If your first card's already a king and you've got that in your hand, there are only 51 cards left. All right, now how many of them are queens? Well, you got a king in your first draw, so there's still 4 queens left in the deck, but there's only 51 cards total left in the deck because you have a king sitting in your hand. So the probability is 4 out of 51. Right? 4 queens, right, divided by 51 cards left. All right, that's how I want to stop that one because the next one's too long to finish into this video. I'll be back for the next one.